NASA and other organizations are planning their first manned mission to Mars within the next decade, but habitations are an issue. Some researchers came up with a very clever idea, but it does involve using people as building materials, and it does get weird. We'll talk about it. Mars soil is basically basalt, but there are a lot of minerals, including hydrous minerals, which is a huge sink for water. Mars never really lost its water. It just ended up being absorbed into the rocks, and it's still there. This research group proposed using two different kinds of bacteria. One of those two bacteria that they proposed was blue-green algae, cyanobacteria. These guys are very present in even extreme environments, and they're extraordinarily useful. In early Earth, before plants ever graced our planet, they produced the breathable oxygen, and they could do it in Mars. The other one is urolithic bacteria. Now, these guys use urea in their metabolism, and they build calcium carbonate from it. Yes, their metabolic byproduct is cement, and it can be used to make self-healing cement here on Earth, so why not Mars? Now there is a problem. It needs urea, something that generally exists where there is life, but there shouldn't be much on Mars because, life. So researchers looked around a spacecraft and realized, hey, there are some producers of urea right here. Astronaut urine. So they need the astronaut byproduct, and together, these can make oxygen and cement. These scientists also envisioned bioprinting, something that we can do on Earth. They could have robots take the cement mixture and print it directly into homes. This heavily reduces the need for, say, astronauts to swing a hammer in a spacesuit. And this is one of the best things about having AI, so things that can learn and grow based on the environment that they are in. Now, there are some limitations, or rather unknowns, for this kind of project. Yes, it provides a low energy and efficient way to make cement, and it could also be used on Earth. In fact, it probably should be used on Earth. Although the physics of it work here, we don't know how all of these things will behave in a low-gravity environment, or at least less gravity. The atmosphere is different, so we don't know how bacteria are going to react. Mind you, bacteria divide very quickly, and they tend to have mutations and adjust pretty well, so I'm not particularly worried about that part. This would probably all happen in a biodome, so we would need to get the dome there before we get all these things up and running, and needing astronauts there as materials is not the worst idea, because somebody should maintain the robots. Now, I do have some bad news for you, and that's that terraforming Mars is not going to happen. We can't even fix our problems here on Earth, but we as humanity have the technology to create a dome, some place where people could live. When we're thinking about how this technology will work, we have to consider the absolute extremes. So think something as cold as -90 Celsius and just as warm as 27 degrees Celsius, which is kind of warm for me, to be honest. I'm still not sure that NASA is going to be able to get people on Mars by 2030. It's less than 10 years away. Just from what is made public, and we as the public do not know everything, it seems like we're not there yet, but we may be surprised. I think the extra pressure from private industry trying to make terrible decisions is going to have some effect. But just know we can't rescue people from Everest, let alone Mars. If you leave for Mars, you're on your own. If you enjoyed this, I'll keep you up to date. Follow for more. If the robots rebel, I will be the one to tell you about it first.